Hi everyone, welcome back to Crafted Jewels. By the way, you have seen 10.11 web methods release. There are some super cool features, and one of my favorite feature is gRPC, and the support of gRPC web methods is just introduced. It is just getting started. I think once it actually supports all the features of gRPC, it will be very, very cool. And this video is all about gRPC and the support of gRPC in web methods. Let's get started. So before getting in, right, let's try to understand some foundation concepts for gRPC. So especially I wanted to highlight about HTTP2 protocol buffers and the gRPC itself as kind of a capability. Okay, and especially when it comes to HTTP2, I would like to highlight HTTP2 is focused on some key capabilities. We cannot cover everything in this video, but at least I'll try to cover few of them, which are really, really important to understand the core capabilities. So HTTP2 comes with the request multiplexing. Just an example of what is request multiplexing. If you see HTTP 1.1, the client and server communication, if the client has to download these three files from the server, let's say from a browser, it actually initiates three TCP connection one after another and then downloads them. Whereas in HTTP2, it can be done in one TCP connection, and it can actually get everything at one shot. With a single TCP connection, it can actually stream all of them. Okay, and of course HTTP2 is focused on compressing the headers to reduce the size of the payload. It operates on binary protocols, unlike the HTTP 1.1, so everything is zeros and ones. And in HTTP2, there is also a cooler feature where server can actually push the cached information to the clients, which makes it much easier for the clients if the session is already established, the connection is already established through the channel. Server can push the data. These are my favorite actually features. There are a lot of other features available. And now let's come back to protocol buffers. And protocol buffers is a framework which is built by Google initially, which offers language neutral, platform neutral, extensible mechanism for serializing the structured data. And the real protocol buff, if you take, right, it will only contain these two things: message hello request, message hello reply. Usually these two are considered as two structures which are containing name here in the request, and reply contains message. This one means the position of the element. And if you have more elements, they will come like 2, 3, and 4, representing their positions and the type. This is more like a machine readable format, especially made for machines to understand. When if you are programming, the conversion would be much faster. The serialization and deserialization would be much faster. And without contract, that means without the proto files, the contracts are defined for the structure. The contracts are defined in proto files. Without contracts, you cannot even operate on top of proto buffs. And it is language interoperable. It has wide range of support for different languages. And I already mentioned machine readable. The top level one, what you see here, service greeter, is just an extension of proto buffers. It is still protofile, still protocol buffers, but it just actually denotes the capability of it just denotes the API greeter, which is actually taking the request and returning back the response hello reply. It takes hello request and responds back hello reply. Just an example, I wanted to show you the difference between HTTP1 and HTTP2. I have a HTTP2 demo, which is actually a page offered by Akamai. Even if you Google HTTP2 demo, you will find a lot of links here. You see httpdemo.io and all those things. And if you just click any of them, right, you can see HTTP 1.1 takes 2.18 seconds, whereas if you run HTTP 2, it actually takes 1.14 seconds. It's not the server processing. Basically, it actually explains. It is the capability of the client processing the data that actually is receiving. Okay, another example, if you want to look at, and because HTTP2 adoption is increasing day by day, and these days a lot of browsers does support HTTP2. Another example which is actually offered by Akamai, if you see, this is HTTP 1.1, which is taking almost like 5 seconds, whereas this HTTP2 takes 3.34 seconds. Almost it is actually reducing half of the time. So that's the kind of a support HTTP2 has, because it actually has request multiplexing. Even if you can go back and enable the developer tools and see how the calls are made if you want to understand more. Now let's get into the support of gRPC. I don't want to actually get into too many details about gRPC because it'll be very difficult to cover in this video. But if you just try to compare this with REST, which we are all aware very well, gRPC is built on top of HTTP2. That's the reason why I showed you the nature of HTTP2, how faster it will be compared to HTTP.1. So with this demo, I think you all will agree that it is faster. And another good thing is gRPC is built on top of Google protocol BUF, which is basically a binary and a smaller format. Compared to JSON, JSON is a text format, and it is larger format. It is made for humans actually. JSON made for humans and browsers, whereas protocol BUF is especially made for the machines where you can actually program and serialize and deserialize. And coming back to contracts, gRPC has a very, very strict contract. Without Proto, you cannot do anything. You cannot even implement a server. You cannot even implement a client. Whereas REST, you can do. You can actually offer your APIs with RESTful approaches, even though you don't have OpenAPI spec or Swagger. Even then, right? If you have a possibility to break the contract with REST. And coming back to gRPC, one of the cooler feature I would say in gRPC is support for the bidirectional streaming between client and server, where REST is more like a request and response kind of a model. gRPC adoption is increasing a lot, whereas REST is de facto standard for almost all the APIs. There is a big fight, actually big debate happening between gRPC versus REST. But I would say that both are kind of made for their own use cases. Choose the right API at the right place. Because there are cases where you might have to be little flexible in terms of your APIs and API specification. And now coming back to the next slide, these are all the RPC types, gRPC types. Unary RPC, it is more like a request response model, something similar to the APIs. And you have server streaming, where client requests and server keeps on sending the stream, and client streaming, where client keeps on sending the stream and server acknowledges once it actually receives. And you have the bidirectional streaming as well, and it actually all happens within a single TCP tunnel. Okay. All right, so let's get into the details about how you can actually implement the gRPC. But I wanted to stress upon one thing. So in webMethods, as of today, in 10.11 version, it only supports unary streaming. You can see the same thing in the documentation. So as of today, only unary RPCs are supported. And you do have also, you don't also have a kind of a flexibility of creating too many channels. There is a predefined channel defined on integration server 10.11 version. Let me quickly open 10.11 version. I'm using a webMethods service designer. By default, webMethods 10.11 comes with the new admin screen. You can go back here to the settings and see the gRPC here, and you can see gRPC. By default, there is only one channel, that is 50051, which is actually tied with the key store and trust store. By the way, the gRPC communication happens only on a secure channel, so bear in mind that. And you can actually enable few more configurations for gRPC, where you want to enable mutual SSL. The authentication can be driven by mutual SSL. I do have already some kind of a sample services here, but let's forget about them and then see how we can actually create a gRPC unary service from scratch. Just in a moment. And I also wanted to show you a few more things, like if you can see gRPC you have two things, not two things, there are more things. I will just apply this. You can see gRPC client certificate, is it required or not? You can say yes, it is required, so that you can enable two-way SSL for the security. And you can also enable the TLS, true or false, and you can also define max concurrent calls and the message size for the communication between client and server. So these are all the extended settings you have available. Nothing requires the restart of the server, so you can actually change them anytime. For time being, I'm not going to enable the client certificates. I'm going to leave everything as is. And let's get started. So I have a proto file which I have the Marvel hero request, a message, hero request, which takes hero name and returns basically success or failed, and also returns errors. And you can see the positions, position 1, position 2, and position 3. And position 3 is referring to errors in another type, basically code and entity. I especially wanted to take this because I'm also a fan of Marvel, and also it has a slightly complex example of a type reference, errors type reference. And finally, you have the service, Marvel superhero service, add Marvel superhero. Okay, so let me take this and create the gRPC unary service on integration server. So I have a package here, gRPC samples package with v1 folder. This is my favorite structure. I will go back to APIs folder and say new. You have this gRPC descriptor, just like I have shown in the previous videos, GraphQL and OData. You do have now also gRPC descriptor, and click on that. I would say Marvel is my service name, and proto file. Let me go back to proto file. I will just select Marvel proto, open, next. And the default channel, as of today, you cannot add new channels, only default channel we can utilize in the newer version. I'm looking forward to have the advanced support in the coming version. I'm pretty sure it will come very well. And with that, okay, so I cannot create it because I already have kind of one service created just before this demo. So let me quickly go back here and just delete the entire folder. Okay, done. Let me create it again. gRPC descriptor, Marvel, next, proto file, open, next, finish. You can pretty much see what are all the services that are already registered. Since I just deleted the folder, you don't see any services, registered services. Now you should be able to see everything here. You can see this is my this is gRPC icon. This is my gRPC service, which has an operation, and this operation has a request, and the body is input record, and the response in the body is output record, superhero, success, and errors. And just ignore these stream observer and stream types because these are kind of added out of the box by webMethods. So this is the service that you would get. Even this looks something similar to how the gRPC connectors or else web service connectors are created. Now, what you have to do as a developer is you have to strictly ignore the second two steps and only use this particular step. You can pretty much see this step here, input record, output record. So if you have to implement, right, my recommendation, never ever implement anything inside the auto generated services, but instead what you can do is you can say add a hero. Okay, next, finish. I will just come back here to this service and just going to grab the input and grab the output here, and for time being I'm going to just map whatever the input I'm getting to the output and say success true, because it's a boolean value. True or false is what I'm going to echo, and I'm going to just drop my input record back here, and I should not change last two steps on next and on completed, because this is kind of auto generated. You can also look at the documentation, but I don't think I need this map step. Instead of this map step, I'm going to basically leave this here. Done. So that's it. My service is ready to serve whoever is the client. But just for time being, right, I can enable two-way SSL, but for time being, what I will do is I'm going to kind of give this permission as anonymous, because you all might know already about two-way SSL. So, and for kind of testing this gRPC service, right, I wanted to use this Kreia tool. I can also use Bloom RPC, but I prefer this Kreia because I felt it is more user-friendly compared to Bloom RPC. So I'll create a project. I had this Marvel project already, so I'll just say maybe Marvel 2 and select the location. Maybe I'll just say, yeah, select the folder and directory name in this one, create is what I will say, and say how do you would like to import this. I will just select the gRPC proto file. Proto file is located in here, Marvel, and save. Boom, it's ready. So you have everything ready. So you have few things just like in Postman. You can also configure the endpoint. My endpoint is we should know that it is SSL, HTTPS local host : 50051, and you can say that a server certificate validation disabled because I do have a self-signed one, and mode is gRPC, web and web text, and integration server supports only gRPC, not web. And I just configured this. I can also configure the authentication, but for time being, since I enabled the anonymous access, I think it should work, and I will go back and say send. Pretty much you get the response you see here, right? So maybe add a superhero. I will add myself as a superhero. I wish. You see pretty much 19 milliseconds. I wanted to show you something, right? So if you see the same thing, I have the same service from here, add a hero. Maybe let me change the permission for this also, anonymous apply. And if you just invoke this as from the Postman, I just wanted to show you the difference also. And if I say send, you can see 27 milliseconds it actually takes. Even if I fire the second time, 12 milliseconds, 17, 12. But pretty much the reason why I'm actually showing this is, if you come back to the Kreia tool and again send this, you can see the amount of time. Execution time is almost same. Amount of time it actually takes for this Kreia client to render the response. That actually makes it much better. That's what the beauty of protocol buff and also HTTP2. It's faster compared to HTTP 1, because this HTTP call that is happening on a non-secure channel, but still it is slow, number one, and number two is basically it operates on top of HTTP 1. So it uses JSON, whereas this uses JSON like protocol buff. Okay. And again, before now, let me come back and see this one. And if you see, right, it actually shows what are the gRPC services which are already registered here. And I wanted to highlight one more thing. There is a new package now called webMethods to support gRPC. So you can go and look at the description about all these things. Pretty much, I think we might be using either on completed, on next, and on error, and the remaining are subject to change because these are public APIs. And coming back to the limitations, right? Again, like I mentioned, it does not support client streaming, server streaming, bidirectional streaming, RPCs yet. And also there are limitations on types, gRPC field types. We don't have the support of enum yet, and we don't have the support of reflection protocol. I'm actually looking forward to see the support for the remaining things in the coming versions. So yeah, that's all about gRPC and its support in web methods. Have fun, keep learning. Thank you very much for watching this.